Welcome back to Simulation and Prototyping. My name is Carl Dobman. I'm the Dean of the College of Architecture and Design at Lawrence Technological University. The tutorial today will take you through 3D printing or prepping your file from the tutorial and module that we're working on to get you to the point where you can have something to be 3D printed. And so if you've made it through the first two partial tutorials for this module, you should have something that might look like what we see over on the side. And what I'm going to do is I'm going to connect a couple of these and do a couple of options and then show you how I would output these to print. So the other thing that I've done in the Grasshopper side is I've made a BREP, which connects all the way back, a BREP container, which connects all the way from the last option here, the last or second to last, the final outputted geometry in our string. I guess we have a moved option there. And then what I did is I just connected to this a BREP container. If I hide this before I go back, that BREP container comes all the way back to the beginning. And the reason why I did that is that I can just bake from here. And so if I change something, or let's say I'll bake this, I do want to group all of these and say, okay, we get this here. I'm going to move it to the side. And then let me make a couple of random changes. And what I'll do is I'll join or union is the right term. I'll union this together with another one. And so I'll select the BREP again, and I'll bake and group this one as well. And now I can move this over. And let's look what happens if I zoom selected. Can even go larger now with Rhino. Once I zoom selected, I'm basically orbiting around these. And I'm going to look at just putting them, overlapping them. So I get something that I might like, these two combined solids. I'm going to select both of them, and then I'll go to solid and union. And this is going to union those two things together. I want to do one example as well that will be a test case for hopefully something that doesn't work. And sometimes when I try and make things that don't work, they still work, but we'll see. What I'm going to do, and you shouldn't do this, but this is something that might occur at some point for you. I just exploded this. I'm going to delete. I just have to unjoin it. I'm going to delete one of the faces on the bottom and join this all back together. Control J. You see it says it joined into one open poly surface. And let's see what happens. The thing that I would do now in my workflow is maybe have those off to the side if I want to output them. And I'll select just the one I want to output, and I will I'll do export selected. And I'm going to export select it as an STL file. So if we come down to the bottom, choose the folder that you want, come down to the bottom and scroll down, they're alphabetical, and look for STL. It's a stereolithography file. It's an older type of format, or an older, there's not so many stereolithography machines anymore, but we still use this file format. So choose STL. I think this one is open. I think this is the one that should not work. And I just want to show you what that might look like, or as a way to test it. And I believe I'm going to just accept the 0.01 millimeter tolerance and say okay, and say okay is here as well. I'm going to export my other one, export selected. I'll call this one massing test closed. And it's also a stereolithography file. I'll say, okay, I'll accept that for the tolerance, and I'll accept that as the default output. Because I just want to be able to come back and reference this, I'm going to minimize this, but open a separate Grasshopper file, or sorry, a separate Rhino file. And now I'm going to open, I don't need to save that. I'm going to open my massing test open, and this one should show us a problem. I'm going to accept these defaults. They work fine. And let's see, I'll look at this in perspective and maybe turn on the ghosted view. And so we can see that it's an open, I deleted that one face on the bottom. What we want to do to test, and I keep using this term watertight model, completely solid. This is not watertight, because if it were like this and we filled it with water and we turned it over, the water would fall out. And so watertight means that it needs to be a completely closed volume. Some of the 3D printing software has gotten better at closing some of those things. There's different ways to deal with it, but I want to show you what kind of way to test before you submit something. We're going to select the object, and we'll go up to Analyze, Edge Tools, and Show Edges. And now what we're asking it to do is to, and yours may say all edges, we want to see naked edges, because a naked edge, again, remember, if this is a completely closed volume, every single edge should be touching another edge, and all of those would be closed. This is a really simple form, but you can see that the pink lines now show us where there's an open edge condition. And so if we were to submit this to 3D print, someone would tell us that it's not printable, it would give us an error, or we would need to fix it. We could go back to our Rhino file, try and find where those problems are. You can get into some really kind of messy situations if you have really complex, really jagged geometry, and it's the smallest of triangles that are missing or something like that starts to happen. For the way that we built this file for this tutorial, I don't think you should have any problems, but if you do, reach out to me and we can take a look at them and try and solve it. So this is, because it has naked edges, this is going to tell us that it's got a problem. We could go in, we could add that face, we could do other things, but we also know that we saved a closed file. So let me open that one. And then we can just confirm that there are no naked edges on this one. Again, Analyze, Edge Tools, Show Edges. And as I spin around, there are no pink lines and there are no open edges. And so this means that it's a watertight solid, and that's good to go for us. Given the way that that Shapeways, or at least showing you guys how to use Shapeways as a process of doing this, I don't really feel the need to save anything. If we want to be more specific, we could go back, and actually maybe this is worth doing so that you can control some of this. I'm going to go back to the Grasshopper file, and let's take a look at it. For its dimensions. I don't want that one, that's the open one. But let's check a dimension here. And we can even see what, sometimes the dimension defaults are kind of screwy. So that's 150. My guess is this is in millimeters. And so we can work in millimeters, we can change it, although millimeters tends to be pretty safe, at least in my experience of moving back and forth between these things. And so what I'm going to do is just look and see 150 millimeters in inches. Google's a really good conversion calculator. And so 150 millimeters is almost 6 inches. And so my overall, if we wanted to understand the overall, a simple way to do that is to do a bounding box. And so I'll delete that. I'll select my object and go to Analyze, Bounding Box. And what this will do is it'll give us a boundary around the whole thing given the X, Y, and Z coordinates. And so that's a useful thing if we want to have a kind of volume and understand what this is. So the same thing, I can go to Dimension, Linear. And so overall, 211, 225. So 225 millimeters is about 8 inches. So I want this thing to be about 2 inches for printing, for what we're doing. And so that'll mean that I want it to be probably 20%. And so I can select both of these. Let's say scale. Select a corner, and then let's say 0.2. So it just got a lot smaller. And 45 millimeters, it's about 1.77 inches. So that's a good size for us to print, because this doesn't need to be a big print. We just want to go through the process of printing. And so let me output this one again. I'll select it. I'm going to export selected as an STL. And I'll call this one massing small, or actually scaled, in case we want to be precise or know exactly what one we're doing. So this is called massing scaled 20%. We'll say OK. We'll say OK. I'm pretty confident that there are no naked edges. And so let me go straight to Shapeways then as a way to show you this. And this is also maybe a good test, even if you're going to print it with someone else. So I'm already logged in to Shapeways, and you can sign up. There's no cost to sign up. And what I would do is I would get a quote. And so let's do that. So we'll get a quote. All we need is our STL file. So click here, and let's test our massing 20%. Say open. Takes a second. And so the first thing that you'll get is a 3D representation. It might take a minute to come in to get the actual dimensions. Once the dimensions are there, you can get options for materials. And so we knew that one of the dimensions was 45 millimeters, which was about 1.77 inches. And so this worked well. This took our dimensions from our Rhino file, from our STL, and is using those exact dimensions. We can also resize something. So if we knew, we can also zoom in on this. We can spin it. We can see that it's completely closed. And let's see. So it looks like it has its own navigation. So left click is to orbit around. Right click allows you to zoom in and zoom out. You can also resize. So this will tell you your volume, how much support structure you need, how many parts there are, but we can also resize this. So if we wanted to be very specific, let's say it was $25 and we only wanted to spend 20, we can resize it here as well, which will just go through this same process, and we can just do it in inches or in millimeters. And you'll see that we can also change millimeters here to inches. So we can get a sense for the size. We can get all of these in inches, depending on if you're going to use someone else, you'll actually get a sense if they can tell you how much it costs to print per volume. You have the volume in inches or in millimeters here. If you want to resize, you can scale up or scale down any of these. And then it gives you a sense of the cost. And so let's see, I think the options that I was looking at earlier is the versatile plastic. You can see you can spend much more. We can see steel, aluminum, brass. You can even have it gold plated, silver plated, platinum plated. Sandstone is kind of cool. It's not that much more expensive actually, but let's just look at the versatile plastic. And then it gives us options here. So if you want to change the color, you can see the upcharge. I would get just white for this. You can see there's different finishing options. I would just do a natural white 3D print, which will be the most cost effective. We can select those, and as we scroll down, it tells us the cost. We can add this to our cart. And you can check on these things. I'm not going to go to the next couple screens. I don't need to share all of my personal information about those things, but you'll see there is tax and there is shipping. And so you can manage those and you can get a sense for what the lead time is once you put in your zip code and all of your information. You can see how long it'll take to get it. And what I like about Shapeways as well is that it just gets shipped right to your house and it'll give you updates along the way. It's going in for printing, it's been printed, it's shipped with a tracking number, and then you'll know when it arrives. So it's a really nice service. There's some really great options for the materials. And so check it out. Otherwise, there may be a local fab lab that could print something for you. Even public libraries sometimes have some 3D printing options. Through LTU, we also have the print lab. And so check out all of those options. But this process, having that STL file, is what you'll need to print for any of these different types of services. So give it a try and good luck. Can't wait to see what you print.